All right, today we are going to start Q3 notes. So we're going to do our page numbering. We're going to start all over again, okay? So this is going to be Q3, page 1. Okay. The title of this page is going to be Systems of Linear Equation Word Problems. Systems of Linear Equation Word Problems. I want you to put your first initial last name, okay? Let some more folks into class. Let me move this thing out the way. Okay, I'll pause for the calls. Okay, so before you can start solving systems of equation word problems, there are some things that you have to know. The first thing that you need to know about solving a system of linear equation word problems, you have to know what a linear equation is. Linear equations are equations that graph straight lines. Linear equations are equations that graph straight lines. Some examples of what your straight lines will look like. I'm going to draw 4 small coordinate planes. And we've talked about what straight lines look like. And I'm going to give you 4 different kinds that have 4 different kinds of slope. Okay? So I have my X and my Y coordinate. X axis, Y axis, X axis, Y axis, X axis, Y axis, okay? So some lines will look like this. They will have positive slope. As X increases, Y increases. It's a straight line going up. Some lines will have a negative slope. As X increases, and remember, X always going to increase because you always read the X axis from left to right. So as X increases, Y decreases, so that gives us a negative slope. So you got lines that go up, positive slope, lines that go down, negative slope. Then you have your horizontal lines. They have 0 slope. It's a straight line that's horizontal. And your last type of linear equation is going to be lines that have undefined slope. Those are vertical lines, straight up and down lines. Vertical lines have undefined slope. Positive slope, negative slope, 0 slope, undefined slope. These are different examples of linear equations. And I'll pause for the calls. Any questions? All right. The other thing that you need to know about solving system of linear equation word problems is what is a system of linear equations. So system, going to define systems of linear equations. So your systems of linear equation, think about system meaning more than one. A bus system is more than one bus. A school system consists of more than one school. A body system consists of more than one body part. So a system of linear equations is more than one equation. More than one equation or linear equation, okay? More than one equation. All right. This is also going to be, so I'm going to put a semicolon because this is another characteristic of a system of linear equation where the meaning of X has to be the same in all of the equations that are a part of that system. So the meaning, where, forgot that important word. where the meaning of x is the same for both equations. For both or all the equations. In this case, because we're only doing 2 equations for these systems, I'm going to say for both equations, okay? But just know a system can be more than, it can be 3, 4, 5, 6, equations. But we're only going to be dealing with 2 equations at a time. Okay? And the meaning for y is going to be the same in both equations. The meaning for y is the same for both equations. Both are all equations. Right. And I'll pause to give you a chance to write. All right. The other thing that you need to know is that linear equations are written in many forms. Linear equations are written in many forms. Okay? The two that we're going to talk about in this particular course is going to be the slope-intercept form and standard form, okay? But there are other forms that linear equations can be written in, okay? And a form is just the way an equation looks. It's what something looks like. So we're going to talk about the slope-intercept form first. Okay. Your slope-intercept form is y equals mx plus b. When equations look like this, where you have your y, your equal sign, your number attached to x, and your number that has no variable attached to it, or it can be the b can come first plus the mx, okay, as long as y is isolated. This, if your equation looks like this, is written in slope-intercept form. Or, of course, b could come first, all right? Okay, your m, the number that's attached to the x, is called your slope or your rate. You can say rate or rate of change. But the number attached to x is your slope or your rate. Your number that has no variable attached to it, b is a number that has no variable attached to it, is called your y-intercept. Okay. Your starting amount. This says starting amount. This is amount here. Or your initial value. Or initial value. And I'll pause to give you a chance to write. Okay, let's keep going. For your x and your y, there are other names that you need to know for x and y. Super important. Your synonyms, or another name for x, is your input values, your domain values, and your independent variable. If they ask you what the independent variable is, they want to know the meaning of x. They don't want you to just list numbers for x. They want you to tell them what is the meaning of x. Okay? I'll pause real quickly. Okay? Synonyms for y, or other words that mean y, or your y values, is your output values, your range values, If they want to know the meaning of y, they may say, what is the dependent variable? If they ask for the dependent variable, they're asking for the meaning of y. They're not asking for you to list the y coordinates. They want to, or the y values, they want to know what is the meaning of y in this problem. Okay. Lastly, another way to say y is f of x or g of x or h of x or t of x. Okay. You don't have to always use f. It's the one that's most popular, obviously, because f represents function. But you don't always have to use f. You can use any other letter you want. Yes. No, because the x is, well, yeah, if x is equal to something else, like x can be equal to 5 or 7 or 2. If you say f of another number, you automatically assume that even though they use that number, it still means x. Does that make sense? Okay. Very good question, babe. Okay. I'm going to pause real quickly. All right. Here, what we know about slope, because you might have to find slope in some of your word problems, is that the formula for calculating slope is rise over run, or y2 minus y1 over x2 minus x1. Okay? If you are looking at a graph, and this is super important. If you are looking at a graph and along the x-axis, they say that this is the number of hours. Number of hours. And on the graph, they say that along the y-axis is the total cost. You then know what the slope, the meaning of slope is. You now know the meaning of slope because look at this. Your slope formula tells you that your y is on the top and your x is on the bottom. So here, the meaning of slope in this graph, y being on top, the unit for y is cost. So cost goes on the top. Your unit for x is hours. So hours goes on the bottom. So then the meaning of m is going to be cost per hour. Cost per hour. I should have took the S off. Sorry about that, y'all. This is super important to know that when you know the meaning of x and you know the meaning of y, then you know the meaning of slope. If you know the meaning of slope, then you know the meaning of x and y because you can take slope and whatever the unit is on top is going to be your meaning of y. Whatever the unit is on the bottom is going to be your meaning for x. Okay. Any questions so far? Do you need more time to write? Please raise your hand or unmute. Okay, I'm going to move on, all right? Okay, this is still going to be considered as page 1 because we're going to take this picture and we're going to put it on the same page, okay? So this is still considered to be this page 1. So I'm still going to put page 1 even though I'm writing it on a separate page. I want to keep all of this concept together, okay? All right. Okay, so the other, if you remember what I was talking about with what we need to understand is that linear functions can be written in multiple forms. And the two forms that I told you that we're really going to be writing these equations in is going to be slope-intercept form and standard form. So now we're talking about standard form. Okay? Standard form looks like this. Standard form is where you have x term plus the y term is equal to the number that has no variable attached to it on the end. Okay, so this is standard form. This is where letters in this form, A, B, and C, are actually numbers. Okay? They're actually numbers. All right? The number that's attached to X, if it's written in standard form, A cannot be, this number right here cannot be a negative or a fraction. Oops. Sorry, y'all. That's dangerous. If I could actually spell, oh Jesus. And I put fraction slash decimal. Okay? It can't be those. All right? Now, the misconception that we sometimes get that just because the equation is not in standard form has nothing to do with whether it's linear or nonlinear. Okay? It just means it's not in standard form. It could still be linear. It's just not written in standard form. Okay? Any questions about that? Okay. Good deal, y'all. Please make sure that you ask questions. This is the last part of these notes, and then we're going to go to the examples. Okay? These are the steps. So now we're getting ready to write steps. And there are a lot of steps. I'm going to go ahead and tell you it's 7 steps, okay? And you're not going to use all 7 steps for every problem, but I don't want to leave anything out, okay? You're not going to use all 7 steps for every single word problem that you're going to do. I just don't want to leave anything out, right? So we have steps for solving system word problems. Okay. Of course, step number 1, you got to read the problem. Super important. Please read the whole thing. Step 2, identify the question. What are they asking? Identify the question. Shouldn't capitalize question. Okay. Identify the question. Okay. When you identify the question, then the third step is going to be so easy. You have to declare the variables. Like, what's missing? When you can figure out whatever it is that's missing, then you can say that X represents this that's missing and Y represents that that's missing. Declare the variables. Of course, again, your variables, if you remember, are your unknowns. This is what you don't know. And you generally get the unknowns from the question. This is what's missing. So if this is missing, we're going to say this that's missing is X, and this that's missing is Y. Number 4, remember, you don't do every single step for every single problem, okay? Don't do that. I just don't want to leave anything out. Number 4, you're going to find important information. Find important information. What is some important information, Ms. Reyes? Those are some really good questions to ask. They may give you slope. They may give you the slopes for both equations. You need to look for that. They may give you the starting amounts or the y-intercept. Probably makes more sense in a word problem to look for starting amount. They probably won't say y-intercept because they usually use the word y-intercept for lines. Okay, so it'll probably be starting amounts or initial value. The other thing to look for is the meanings of X and Y. And sometimes they'll give you totals, which your total is always going to be your Y. Okay? Your total, they say total, something that's going to be more than likely be your Y. All right? Number 5, you're going to write the equation. From all this information now that you have, you can then use that information to write an equation. The equation that you're going to write is either going to be written in slope-intercept form or standard form, possibly. Okay, those are the two ways that we're going to be writing equations when we're doing these problems. We're either going to write it in slope-intercept form or standard form. And maybe not all the way standard form, maybe just in AX plus BX. It might be in the right order, but the first number might be a negative. And most of these, not so much, because these are real world examples. So most of these are written in standard form or your slope intercept form. Okay. Number 6, this is where you're going to decide how you're going to solve it. What method are you going to use? Decide. We've already talked about this. What method to use to solve. And remember, the 3 methods that we've been using is the graphing method. We either graph them to see, graph the equations to see where they cross each other or if they cross at all. Or we use the substitution method. Or we use the elimination method, which most of you said the elimination method was the easiest method. And remember, I told you it was 7 steps. So the very last thing that you're going to do is check your answer and make sure that your answer makes sense. Check answer and make sure it makes sense. Okay. And those are your 7 steps. A lot of steps. Remember, we're not going to use all 7 steps every time you do a word problem. But this is guidance to help you through these word problems and solving them. Some of us may need more help than others, and so we need to go back and refer to these, okay, to help us along the way. But you are not going to use all 7 steps for all of these word problems, okay? Any questions before I stop? Okay, so now I'm going to do one of the guided practice problems. This is what's on the Canvas page, on our weekly page, guided practice problems. This is the title here. I'm going to do the first one and you're going to do the second one on your own. All we're doing today is just setting it up. We'll come back tomorrow and solve it, okay? We'll come back tomorrow and solve it. Today, we're just setting these up. Go ahead, okay? No, you're fine, baby. All right, so we are going to set these up. We're going to write the system for both of these, okay? And we're just going to solve the system tomorrow. Does that make more sense? All right, so let's look at the first one. I'm going to do the first one and set it up, and then you're going to set the second one up on your own. And then we're going to come back tomorrow and use the graphing method to solve them. Second. Okay, so let's look at the first one. It says, Anne is trying to choose between two phone plans. Got two phone plans. The first plan with Vanafon or whoever that is costs $20 per month. Okay, so it's $20 every single month with calls costing additional 25 cents per minute. So let's look at that first company. All right. The starting amount for the month is going to be $20. So that's my B. That's my starting amount for the month. My rate of change is going to be, says, in addition to 25 cents per minute. So it's going to go up 25 cents per minute for every call that is made. Don't put zero here. This is 25 cents. Miss Reyes, how do you know the difference between what's my B and what's my M? My B is my starting amount. My starting amount for the month is going to be $20. Okay. Then I'm going to add 25 cents for every single minute. So that's going to be the rate that is changing. So that's how I know the difference between my starting amount and the rate. Okay. All right. So the equation here is going to be Y is equal to M, which is 25 cents, times X, plus my starting amount is $20. All right, how do I know what X and Y is? They gave me M. I'm gonna put right over here in the corner. My M is 25 cents per 1 minute. The units on the top is the cost. That's the money. It's cost. Okay. The bottom is minutes. So that means that my meaning for Y is the total cost, because Y is always going to be equal to all of this. So this is total cost. And my meaning for X is going to be the number of minutes. So that means this is the number of minutes here. All right, so now let me do my second company. The second company charges $40 for every single month, but it only costs 5 cents per minute. So again, my starting amount is going to be that $40. My rate is going to be 5 cents. That's 0.05 cents for every single minute. So then the equation that I'm going to write for this second phone company is going to be Y is equal to 5 cents times X, which is the number of minutes, plus a starting amount of $40. So now I have a system of equations. I have two equations where the Y in both of the equations represents the total cost. The X in the equation represents the number of minutes. Questions about that? What they want us to do is how many minutes are plans. Okay, so they want to know when is it going to be the same amount of money. So where do they cross each other? That is going to be the solution. When is X going to be the same as Y? And remember, I told you we'll solve this part tomorrow because we're going to graph to figure out where they cross. So your task today is to set the second one up in the same way that I set this first one up. Any questions about that? Okay. Any questions before I stop the video? All right, so that's what I need you to do. I need you to go ahead now and set up question 2. Guys, as soon as you get a chance, I need you to work on, you have a flex day tomorrow. You need to be working on your Delta Math assignments, because remember, everything is due on Friday. And you need to make sure that your diagnostic test is completed. Most of us have finished. There are maybe about 3 people literally that have not even started. Please, it's so important. You cannot do the iReady project if you have not finished the diagnostic test. And that's a major grade. Please make sure that you finish that. All right, I'm going to go ahead and stop the video. Remember, you can rewind, fast forward, ask questions to remind, do whatever it is you need to do. Come to office hours tomorrow if you need help.